Hello everybody and welcome to another tutorial. In this tutorial we'll be learning how we can create a network using 3 computers and 1 switch of type 2950-24 using star topology and Cisco packet tracer. So this is going to be a tutorial on Cisco packet tracer, and here we'll be learning how to create a network on star topology. So before we can go ahead with this tutorial, let us do some background research on star topology. So here I've done a Google search on star topology. Let us study the definition of star topology first of all. So it says it is a network topology where each individual piece of a network is attached to a central node, often called a hub or switch. The attachment of these network pieces to the central component is visually represented in a form similar to a star. Star topology is also called a star network. So here basically we create a network that resembles a star-like shape or has a star-like outline. So I don't know whether you're aware of this symbol of star, the star symbol. So this star symbol can be popularly seen on Xmas trees, that is Christmas trees on the eve of Christmas. This is actually the Star of David. It is a pretty popular symbol that is used by the Christian and Jewish people all over the world. So the reason I'm showing you this symbol is that you can see that this symbol is pretty similar to the layout of the star topology that we can see here. So there are 1 2 3 4 5 6. So it has 6 corners, and here also 1 2 3 4 5. We've got 5 corners, and all of them are centrally connected to a switch or a hub or a router in the middle portion. So this is the star symbol, and this layout or the manner in which the computers have been arranged in this network, they are both pretty similar. So the arrangement of computers on this network resembles a star. So for that reason we actually refer to this protocol or the topology as the star topology. Let us check some other images of the star topology. So here you can see, here is another image. So they have connected 1 2 3 4 5 PCs using a hub in the center, and here also you can see there are multiple devices connected, some PCs, a printer, and one more desktop PC. So all of these devices have been arranged in accordance with the rules of the star topology. Here is yet another image. So let us study star topology along with its pros and cons. Star topology is also called the star network. So it is, as I've said before, it is a network topology where each individual piece of a network is attached to a central node. The attachment of these network pieces to the central component is visually represented in the form similar to a star. So this shape or the manner in which the computers and other devices are arranged in a network, this resembles a star-like pattern, and hence this topology is called a star topology. So it says star topologies are either active or passive networks depending on the following: if the central node performs processes such as data amplification or regeneration, if the network actively controls data transit, if the network requires electrical power sources. So these can be of active or passive types. So it primarily depends on what kind of device you are connecting your computers or the clients to. So the clients in a network are connected to a central device. So maybe it can be a hub or a switch or a router. So depending on what kind of device you are using, it can be either an active network or a passive network. So typically hubs are not dumb kind of devices. They are not intelligent devices. That is, they can only forward the data that it receives on one port to all the other ports. That is, it performs a broadcast kind of traffic control. It is not capable of performing unicast traffic. That is, it cannot propagate the traffic in a unicast mode, and it does not maintain any kind of routing table or switching table. So if we want to send a data from one node to another node, it will be forwarded to all the other nodes that are present on the network. Say we want to forward a data packet from from a node A to node B on a network, and let us assume that there are other nodes on the same network, such as nodes C, D, E, F, and so on. So when we are trying to forward the data packet from node A to node B, it is intended that the receiver of that particular packet will be node B itself. But what happens is that if we use a hub, nodes C, D, E, and whatever other end devices there may be in the network, all of them end up getting the same packet. So as the hub usually broadcasts the traffic to all the other end devices that are present on the network, it results in network congestion. So a lot of traffic is generated unnecessarily, because to transfer one packet from one device to another, multiple copies of the packet are produced and they are sent to multiple devices all over the network. So this results in the wastage of bandwidth. So these kind of networks are typically known as passive networks, because the hub, which is controlling the flow of traffic, that does not have the ability to control the flow of traffic or to send data packets from one particular sender to a particular receiver. So it lacks any kind of intelligence. But unlike hubs, if we use switches or routers, they are a lot more advanced than hubs, and they have the ability to regulate the traffic from one device to another. So a switch based on the IP address and the MAC address of the receiver, it can forward the data packet that is intended for the receiver properly. That is, it does not send the data to all the other connected nodes. Say if we want to send the data from node A to node B, the switch will maintain a table inside itself, and in the table it will have the IP address as well as the MAC address of node B. And what it will do is, the moment we send the data packet from node A to node B, it will just look up the MAC address of that particular node and it will send the data to that node only. So the other devices that may be present on the network, say node C, D, E, F, and whatever devices may be there, that is clients, they will not receive the same packets, because that is not intended for them in the first place. Unless you explicitly configure the switch to operate in broadcast mode, the other end devices on the network, they will not be receiving those packets. So this is all there is to it about active and passive networks. And so here is some more information on what kind of cabling is used for star topology. So it says it can be implemented with Ethernet cable structures, wireless routers, and other components. In many cases, the central hub is the server and the additional nodes are the clients. So in our demonstration using Cisco Packet Tracer, we'll be implementing the network using cables only. We'll not be using any wireless configuration. So for the sake of this tutorial, we'll be sticking to the Ethernet or cable structures. So you may be having the notion that it is not possible to implement star topology in a wired wireless format, but that is not actually true. It can be implemented in wired as well as wireless configuration. Alright, so here, in case the central hub may also act as the server, and the additional nodes, that is the end devices, can act as the clients. So what are the pros and cons of a star topology? So here it says, has the ability to limit the impact of a single failure. In star topologies, a single unit is isolated by its relationship to the central hub, so that if a component goes down, it only affects that unit's local reach. Facilitates adding or removing individual components to and from a network for the same reasons. So here it says, let us take a look at the diagrammatic representation. You can see that all the end devices are connected to a central node or a central hub or a switch. So in case any of these devices go down, it will not affect the performance or the functionality of other devices that are connected to the hub. Okay, so let us say this particular device has stopped functioning for some reason. So this will affect only the communication between this hub and this device only. but the other devices on the network, they will be unaffected, unlike a bus topology where the failure in one node affects all the other nodes as well. Here this kind of thing doesn't actually occur. Okay, so this is one of the advantages of star topology, that a failure in one node doesn't affect the functionality or the performance of the other nodes. Facilitates adding or removing individual components to and from a network for the same reason. So you can add or remove devices from this network whenever you feel like. It doesn't affect anything. Okay, so even if you were to add say 5 or 6 more devices to this network, it will not affect the performance of the network. And the amount of cabling that is required to set up each devices, to set up the connection between one device to the hub, that is also relatively less as compared to the amount of cabling that is required for something like a mesh network or a bus topology. Okay, so here the only connection that exists is between the end device, that is the PC or laptop or any wireless device like phones, PDAs, etc., and the central node. So to connect these devices, it doesn't require a lot of cabling, only a small amount of cabling is required. So it is kind of an economical solution. So here they have not listed any kind of cons of the star topology, so let us see if we can find some information on the disadvantages of star topology. So here we have another website, so let us just take a look. So here it says, here are a lot of points under the advantages section. So some of the points that we have already covered earlier. It is very reliable. If one cable or device fails, then all the others will still work. It is high performing as no data collisions can occur. Less expensive, easier to put in, robust in nature, easy fault detection because the links are often easily identified. No disruptions to the network when connecting or removing devices. Each device requires just one port to attach to the hub. If n devices are connected to every other in star, then the amount of cables required to attach them is n. So it's easy to set up. So I've already gone over some of the points that are a part of the advantages of star topology. So it is a reliable device because if the network fails, it doesn't affect the performance of the other devices that are connected to the same network. It is relatively cheaper because the amount of cabling required is quite less, and the number of ports required to facilitate a connection between a hub or a switch and the end device is only one. And it is easier to detect and identify faults in the star topology. Okay, so let us see some advantages. Let us go through some disadvantages of star topology. So it requires more cable than a linear bus. Okay, so here it says it requires more cable than a linear bus. It is actually logically true from a logical standpoint, because in a linear bus we actually have one cable that runs across the entire network. So although it is an unreliable method of transmission, it is actually cheaper. But in case of star topology, as you can see in the diagram, we have to connect each devices individually to the central node. So for that reason it requires more cabling. So more expensive than linear bus topology due to the value of connecting devices. Okay, and if the connecting network device switch fails, nodes attached are disabled and can participate in network communication. So this is one of the most important disadvantages of star topology. If for some reason all the nodes are okay, but this central node, that is the central hub, stops working, or if it goes down, then all the connected devices will also stop functioning at the same time. That is, they cannot communicate between one another, because this central node or central hub acts as a central point of communication between all the devices that are present in the network. So in case something happens to this node and it doesn't work anymore, all the communication across the network will come to a standstill. That is, it will disrupt the communication between all the devices on the network. So this is one of the major disadvantages of star topology. If hub goes down, everything goes down. None of the devices can work without hub. Hub requires more resources and regular maintenance. as it's the central system of star. Extra hardware is required, hubs or switches, which adds to the cost. Performance is predicated on one concentrator, that is hub. So we have studied some advantages and disadvantages of the star topology. So by now I think you can understand what the star topology actually is and what are its pros and cons. So so let us now implement this star topology in a Cisco packet tracer and find out how it actually works. So for the sake of this demonstration, we'll be building a network like this. So originally we wanted to include 3 pieces, so I'll be including 5 pieces. So let me change the description of today's assignment to 5 pieces from 3 pieces, so it will be easier for me to implement and demonstrate to you guys. So in a star topology, all the cables run from the computers to a central location where they are all connected by a device called a hub. It is a concentrated network where the endpoints are directly reachable from the central location when the network is expanded. Ethernet 10/T is a popular network based on the star topology. For network topology, we'll be building 5 generic PCs which are connected to a single switch. Okay, so let us try and implement this thing in practice. So first of all, we'll be taking some end devices. So let us take some computers. So let me just press on control and take 5 devices. Okay, and now I'm pressing the escape key to deselect this particular option. And now let me position the devices properly so as to make sure it looks nice. Okay, so here you can see there are 5 pieces in total. Okay, now let me use networking device. So in our description we had said that we'll be implementing this network using a switch. Okay, so let us take the switch. So do we have 2950 over here? Yes, we do have 2950. So we can use either a switch or a hub. So in this case we'll be using a switch, and to connect each devices we'll be using each of these devices to the switch will be using straight through cable, because we'll be connecting 2 distinct devices to each other, so we'll be using straight through cable. So here I'll be selecting this connections option, which is represented by a Thunderbolt icon, and then from this list of all the cables that are available I'll be selecting the straight through cable. Okay, so now in order to connect, okay, let me just deselect it and click on control and click on the copper straight through cable. I'll be clicking the control option because I want to use this connection multiple times over my network, so I don't want to keep clicking on this icon repeatedly over and over again. So for that reason, to make sure that this device remains selected for multiple uses, I'll be using the control key. I'll be pressing the control key while selecting this option. So now let me connect this thing. So I'll be connecting it via Ethernet. So I'm connecting it to the switch. So here you can see when I hover my mouse pointer over the switch, here you can see that a list of all the available ports in the switch are shown. So here there are 24 ports, so this switch consists of 24 ports. So I'll be connecting it to the very first port, that is the port number 0. Then let me connect it once again to the second device. Here, as port 1 is already occupied, I'll be connecting it to port number 2 of the switch. And now I'll be connecting this third device to port number 3 of the switch. So all the connections are facilitated by using fast Ethernet. This goes to fast Ethernet number 4, and this one goes to fast Ethernet number 5. So all these devices are now connected to the central node, which is the switch, and here we'll be doing something. We'll be assigning IP addresses to each of these devices. So let me now deselect the this icon by pressing the escape key. Okay, so let us now take a look at each of these devices closely before we configure these devices and assign IP addresses to them. So if you click on this icon, you can see it shows all the details regarding each of these computers. Okay, so you can assign other parameters or other devices. You can attach other devices or configure this system from this particular tab. So here, in order to assign IP addresses, we'll be using the IP configuration option that I'll be showing you a little later. So you'll get a similar kind of interface for all the PCs that are present on this network. So to access this interface, simply select this PC and single click on it, and it will show you this interface where you can add additional devices to this PC and also configure other related parameters of this device. Okay, now let me take a look at this switch. So here you can see, as soon as I clicked on the switch, it shows a diagrammatic representation of the switch, and at the rear of the switch you can see that there are 24 ports numbered from 1 to 24. So there are 24 ports at the back of the switch, and this switch is currently active. That means all the connections are now working. Okay, so before we can go ahead and actually test how this connection is functioning, we have to assign IP addresses to each of these devices. Alright, so to assign IP addresses, I'll be selecting each device and single clicking on it, and then from this option, so from this window, I'll be selecting the desktop tab, and under desktop tab I'll be clicking on the IP configuration option. Okay, so here what we'll be doing, we'll be assigning a static IP address. So let me select 10.10.10.1. so subnet mask will be this one. It is the default subnet mask, and I'm not changing it right now, and all the other parameters will be leaving them at their default values for now. Will not be changing them. So the IP address of the first device is 10.10.10.1. Okay, now let me assign an IP address to the second device. So in a similar way, I clicked on the icon of the second device, and then I clicked on the IP configuration option. Now 10.10.10.2. Then I'll be clicking on this IP configuration option a third time for the third PC, and I'll be assigning an IP address of 10.10.10.3. So here, if we just hover our mouse pointer over these devices, you can see the IP address of this device is already showing. It's 10.10.10.1, and the subnet mask is /8. In a similar way, the second device has an IP address of 10.10.10.2/8, which is actually the subnet mask. So now let me assign an IP address for the fourth device. It will be 10.10.10. So while assigning IP addresses, make sure that you are assigning an unique IP address to all the devices. Don't assign any kind of any IP addresses that are in use by other devices on the same network, so it will cause a clash. So 10.10.10.5. and to assign the subnet mask, you can either click on the subnet mask field, or you can simply press the tab key. So whenever we press the tab key, the subnet mask is assigned by the system by default. So all the devices are currently have been assigned IP addresses. So now we can just ping one device from this machine to this machine, or from any other machine to any other machine, and we can check whether the network is fully operational or not. So here you can see on each of these connections, there is a green icon, which means the system is currently functioning and there are no faults in the system. So if this at any stage these green arrow icons are replaced with orange or red colored icons, it will indicate that the network is currently not functioning. Okay, so let me now configure, let me now run the ping command from these devices. So to run the ping command, I'll be clicking on this interface and then I'll be going to the command prompt. So this command prompt will actually emulate the command prompt that we have in Windows. So if we select the command prompt option in Windows, we get something very similar. So in Cisco Packet Tracer, what it is doing, it is simply emulating the same interface of the command prompt that we have in Windows. So from here I'll be from this PC I'll be pinging the fourth system, or rather the fifth system, and the IP address of the first machine is 10.10.10.1 and the fourth one is 10.5. okay, so let me just run the ping command now. 10.10.10.5. so here you can see whenever I try to ping, it is working just fine. So let me ping another device. So this time I am pinging the fourth system and ping has returned successfully, which means the network is fully functional. Okay, and now let us just try to send a packet from one of these devices to another device in simulation mode. So to send a packet, what we'll be doing is we'll be going to this option, add simple PDU, so this envelope icon. So I'll be sending one packet from the first machine to the fifth machine. So to send the packet, just click on this add simple PDU option and then click on, when the cursor changes to this envelope symbol, just click on the sender device and the receiver device. Okay, so now the packet has been assigned to these devices. So let me just turn on the simulation mode and let me simply start the simulation. So to start the simulation, I'll be clicking on capture then forward. So here you can see the device and the packet from the first machine, that is machine 0, arrives on the switch. So let us now click on the capture then forward icon and see what happens next. So this switch now forwards the packet to the intended receiver, that is the fifth machine. So it does not forward the packets to machines 2, 3 and 4, only to the intended receiver, that is the fifth machine. So now this fifth machine is sending a reply back to the first machine. Okay, so now it is successful. So once the acknowledgement is sent from the receiver to the sender, the transmission is completed. So you can also test the functionality of all the other nodes that are present on the network by trying to send packets from one device to the other devices. So this is what the tutorial of start topology is all about. So you can add multiple devices, you can add more nodes to the network, and you can check how it works, how it holds up. So I'll leave you to perform more experimentation with this configuration of network. So you can mix and match devices, and you can add more devices to the network should you feel like, and you can find out what happens and how the network operates under those circumstances. So you can learn more by experimenting with this configuration. But I'll be ending the tutorial here, so hopefully you understood whatever it is that I tried to teach you today. And if you have any doubts and queries, please feel free to ask in the comment section. So that's all for today, and take care guys, and have a nice day.